Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we're going to talk about the Facefish Linux Backdoor spreading over the internet. Facefish is analyzed recently by the Qihoo 360 NETLAB team, who actually coined the name Facefish. It can be used to steal device information and login credentials. It can execute arbitrary commands. It can bounce the shell on the infected Linux system. Now, its name is inspired by the fact that all communication between the infected system and the control server is encrypted using the Blowfish cipher. Therefore, it conceals the malicious activity. The backdoor specifically targets Linux X64 systems and is capable of dropping multiple rootkits at different times. This fact alone should squash any of the ongoing discussion that I've seen in numerous forums where people have asked, should I have an antivirus or an anti-malware on my Linux system? The answer for me is yes. If you have watched my episode on installing ClamAV on a Linux-based system, then you will know that ClamAV, normally an antivirus, also has rootkit detection. So, if you have ClamAV installed or an anti-malware or an anti-rootkit software installed on your Linux system, then it helps. It's one more piece of armor to help protect you against these types of attacks. This attack has been analyzed a few times in the past, including back in April 2021 by Juniper Networks against servers that were running the CentOS Web Panel, also known as CWP, which was formerly the CentOS Web Panel. The purpose of this attack is not fully known, but the hypothesis is that these infected machines would be sold as a part of a botnet. Facefish is what we're going to take a look at today, along with steps to take to avoid this happening to any system you control. Here's a quick look at the agenda. We're going to look at what is Facefish. We're going to look at the anatomy of the attack, how does it work, and we are going to look at steps to improve. So what is Facefish? Again, I mentioned the name was coined by the Qihoo 360 NETLAB research team, who researched it in the infection case, but before that it was done by Juniper Networks and a number of other companies. But according to Qihoo, Facefish consists of two parts. Or their research, it consists of two parts. There's the dropper, and then there's the rootkit. And its main function is actually determined by the rootkit module. It works at the Ring 3 layer and is loaded using the LD under preload feature to steal user credentials by hooking the SSH and SSHD program related functions, and it can also execute arbitrary commands on the infected Linux systems. So by abusing this new Facefish backdoor, a threat actor can encrypt the communication to the server controlled by the attacker with the help of the Blowfish cipher, as I mentioned 2 other times in the intro. Not only that, it also allows an attacker to deliver several rootkits at distinct times. So each rootkit controls the function of what's going to happen. So you can have multiple rootkits that have different functions. One is to exfiltrate data, login credentials, etc. One could be to scan the network for any Windows-based machines that they can then try to do a ransomware against. One could be to look for databases and try to exfiltrate data, or look for trade secrets, or whatever. Facefish goes through a multi-stage infection process which commences with a command injection against the CWP to retrieve a dropper, which is the SSHINS, from a remote server. It then releases a rootkit that ultimately takes charge of collecting and transmitting sensitive information back to the server, in addition to awaiting further instructions issued by the command and control server. So if you look at the screenshot here that I got from the research article from Qihoo 360 NETLAB, you see that they first, they check the environment, they decrypt the configuration, right, to get the control server IP address and port, and how often it should be polled. They configure the rootkit, and then they install and execute the rootkit, and then finally you would see in your lib64 this libs.so binary, and that is the Facefish rootkit module. So the dropper comes with its own set of tasks, chief among them being, again, detecting the runtime environment. It decrypts the configuration, as we just saw in the screenshot. It configures the rootkit, as we just saw in the previous screenshot, and it starts the rootkit by injecting it into the secure shell server process, SSHD. Now, rootkits are particularly dangerous as they allow attackers to gain elevated privileges in the system, allowing them to interfere in core operations conducted by the underlying operating system. This ability of rootkits to camouflage into the fabric of the operating system gives attackers a high level of stealth and evasion. Facefish also employs a complex communication protocol and encryption algorithm using instructions starting with 0x2xx to where the last XX would be number like 00, 01, 02, and 10, etc. to exchange public keys and Blowfish for encrypting communication data with the C2 server. C2 stands for command control. Some of the C2 commands sent by the server are as follows: a report to stolen credential information, collect details of the uname command, run reverse shell, execute any system command, send the result of bash execution, and report the host information. So now we're going to run through an example, or we're going to run through sort of the infection process step by step. So this chart, we're going to go through it step by step to see at each step, at each phase, what happens here. Step 1 is the attacker. The attack starts with a command injection against the control web panel in this example. There are other ways that this can be implemented, but the one that was reviewed, or one that was analyzed, was using an exploitable or vulnerable control web panel. Now in 2020, there were over 215,000 control web panel installations that were accessible from the open internet. So the attacker finds one that's vulnerable, and what does he do? He passes a post command with his attack. It's basically the initiation of the attack. Now, if you look at Control Web Panel, it has been plagued by security issues, including there were 37 zero-day vulnerabilities that were disclosed by the Zero-Day Initiative back in 2020. Among these was a failure to sanitize the service restart parameter, which follows a similar set of vulnerabilities that were found in 2018. So if you look at this command here, where's my mouse? You see that they're sending a post to the admin index PHP script, and they're sending a bunch of variables. So here's the script, right? Client, including client index, and then you see here this variable service underscore start. And as I said, the service underscore start restart or start and restart is not sanitized, meaning anything I type in there, like I love my mom, would be passed through, right? And in this case, they're not sending something as nice or loving as I love my mom. They are sending a bunch of commands, which are then executed. The first command is change directory to the user bin, cd/user/bin. You see right here. The next is to download using the wget command, user bin wget, to download the sshins from this IP address. 176.111.174.26, which we'll later see was located as being a Russian IP address that was on a Bulgarian web host. Right, and then they follow the download up with changing the permissions to 0777, and then running that application, and then doing a number of other commands. Right. So, what happens next? As we saw in the screenshot, as I described, the first command in the exploit post downloads the sshins install binary. Now this binary is a 64-bit Linux ELF executable that's packed up in a UPX, and then the packed file has like garbage bytes appended to it to try to stop it from being automatically unpacked. You know, like if there's like it's like having a zip file that has an error, you know, maybe the whole thing hasn't been downloaded or it's just garbled and it can't be unpacked. Following the download, the binaries, the permissions are changed, as I mentioned when we were looking at the screenshot just before, so that it can be executed. Then it's executed. So once it's executed, and we'll go through the different steps of the execution in a second, but I just want to make sure we understand that first they download it, they execute it, to run, to do the infection and install the rootkit, and then once it's executed, then they delete it. And not only do they delete it, but they wipe the logs, so you can't see what happened. Right, the logs are gone. You can't see that these commands were run. So, the execution of the binary. So during the execution process, before they delete and before they wipe the logs, the execution performs a few tasks. The first one is it drops a Linux shared library to an architecture specified location. Right? It's the lib64, and then they put in this libs.so library, shared library. It writes the name of the dropped file to a text file at etc. ld.so.preload, and then it restarts the OpenSSH. So in the restarting of the OpenSSH, it loads this library, right? And the library basically it injects the LD preload. It decrypts and passes information through to the command control center. It runs a reverse shell. It runs arbitrary commands. It has the potential to run arbitrary commands. And then, so once the OpenSSH service is restarted, the attacker can use this SSH and SSHD service without detection. Right? They can once they receive the credentials. They then have access to it, and because that communication is encrypted using Blowfish, they are highly undetectable. So how do they get undetected? And that's by hijacking the OpenSSH server process. They inject the malicious code. So this file, this etc. ld.so.preload, contains, that they put in the etc. folder, that contains a directive to the dynamic linker telling it to load the specified shared library first. So this X64 folder lib.so library will be loaded first, and then to give precedence to the exported functions from this library. So if I rewrite a bunch of Linux functions, this preload says use these functions and don't use the standard operating system functions. So because the malicious libs.so library exports its own version of the bind function, this is what I was just saying, use my bind function, don't use the operating system's bind function, the applications will use the backdoored version of this function instead of the standard implementation from the Linux system libraries. Pretty sneaky, sis. So when the OpenSSH server daemon SSHD restarts, libso will first execute an initialization function as the library is loaded, and then has the ability to inject its own code whenever SSHD calls bind. So the SSHD server process uses this hook in order to periodically beacon to the command and control server and to exfiltrate data, including a listing of system information such as CPU and operating system details, amount of RAM, available disk space, and open SSH configuration. So here's a screenshot that I got from the research that they did at Qihoo 360 Labs, where you can see, that they're exfiltrating the architecture, i386. They're looking at the system, looking at the host, grabbing the kernel, grabbing the release, the CPU, RAM, ASNI, known host, SSD configuration, interfaces, yada yada yada. So, in addition to the continuously running server processes, SHD forks a pair of new processes to handle each login connection. From these session-specific processes, the malicious bind function that came from the libso and it has precedence over the standard Linux bind function launches an additional temporary SSHD process that then exfiltrates the incoming user's login credentials. So, let's say the rootkit is installed. Nothing's happening right now, but then you want to SSH into your server. You SSH into your server, right? And then the bind function is called, not the operating system's bind function, but the one from this libso. This hacked, or this malicious bind function spawns off a new SSHD process, which takes your credentials once you connect, and it passes them off to the command control center. So now the hackers then have your credentials to access this particular system, and then they can do whatever they want. So the command control communication, how are they talking to each other? As we know, as we talked a few times, they're using Blowfish to encrypt this communication, but the C2 communication within the attack reviewed involved the server, as we saw within that post command, 176.111.174.26 on port 443. Port 443, as we hopefully all know, is typically used for HTTPS traffic, but here the traffic is raw TCP, so it's hiding in plain sight on a common port. The server, as I had mentioned before, had a Russian IP address, and it was associated with a Bulgarian web hosting provider. The client initiates communication with a simple directive, padding out to 8 bytes. The malware uses an encryption algorithm with an 8-byte block size, but even unencrypted messages are always a multiple of 8 in length. Following is the first packet sent to the server after the TCP handshake with the 8-byte message highlighted. So you can see here that this is the 8-byte message that's highlighted here. Now this is very technical, whether you need to know this information or not. If you can sort of digest it, it's great. But this is not necessarily necessary for you to be able to deter from this. But it's pretty interesting stuff. Pretty good to know. Now the response consists of a header with a payload length of 24 bytes, a command 0x0201, and the CRC32 checksum of the actual payload. The 24-bit payload is used to encrypt the exfiltrated data that is then sent back to the C2 server. So they are encrypting the information and the communication back and forth to ensure that it cannot be siphoned off or can be checked for within your traffic logs as something that's malicious. So your firewall would only see connection to this external IP address, but it wouldn't necessarily see what's in the data, be able to read what's in the data packets because they're encrypted using the Blowfish. So we know how it works. We know what it is. We know how it works. We know how it gets there. How do we stay safe? First thing we do is we want to educate our users. So, I'm not talking about, secretaries and that kind of stuff. I'm more talking about the people that are involved in the system control, system administration, setting up new servers and doing updates and whatever, depending on how large your IT team is. You want to educate them to spot suspicious emails or activity and contact their superiors or contact the people responsible for looking into this if they encounter anything suspicious. You definitely want to make time for regular offline backups. This goes without saying for anything. It doesn't matter if you're talking about ransomware, if you're talking about hacks, if you're talking about vulnerabilities. You want to make sure you have time for regular offline backups. When I say offline, I mean that it's not something that's connected into your network anymore. It's stored somewhere on ice, so that if it happens to be a ransomware or it happens to be an infection, these backups cannot themselves then ultimately be infected. You would be able to have a clean start with the system from a specific date and time. You want to have a plan and review it regularly. Of course, systems change, requirements change, new vulnerabilities arise. This Facefish is relatively new. So you want to be able to review your plan and review the steps that you take to review your systems and your software, etc., to make sure that it's up to date, that it takes into account these new types of attacks. You want to review your infrastructure, your hardware, your software regularly. You definitely need to make sure you're checking your systems, you're checking the logs, you're checking to make sure that the software is up to date, to ensure that you have the most limited access for these attacks as possible. You want to update your systems regularly. That goes along with the previous statement of reviewing your infrastructure and reviewing your systems. You review them and you update them. You want to restrict write permissions on servers, specifically file servers. You want to make sure that, again, it's not specifically known what this rootkit can be used for, but it's possible that you have Linux systems combined with Windows systems, and one of the rootkits could be looking for Windows systems that they could then perform a ransomware attack on, like an Exchange server a ransomware attack. Or so you want to make sure that the write permissions on this system and on external systems from this system are protected for that very case. You want to use advanced endpoint protection. Again, I go back and say better safe than sorry. You want to make sure that you have some type of endpoint protection, antivirus on as many systems or all the systems that you have, because it's not just a Windows problem anymore for hacks. Linux is being attacked more and more and more and more. Hacks and vulnerabilities are being found in these systems, or software that is run on these systems, like CWP, the control web panel, with 215,000 that were openly accessible over the internet in 2020. Now, if you haven't already, I would highly suggest you watch my episode on installing ClamAV on Linux systems, because ClamAV does have a rootkit detection engine. Okay, so you then want to use email and web protection to block access to malicious websites and scan all downloads. So you never know whether or not a malicious website could be the initiator, either through cross-site scripting or redirect attacks that can ultimately then download it onto one system, and then it could be spread throughout your entire network. So you want to make sure, for full protection, that you use email and web protection. You want to restrict outgoing connections where possible. Now, if you think about this attack, you had a rootkit that was connecting to a command control server on a specific IP address. So if you restrict outgoing connections from your servers to only known known systems or known networks, like for example, to install updates on Linux, or to connect to GitHub or GitLab, wherever you have your source code. Restricting these outgoing connections so that it can't just go willy-nilly to any external source would limit the ability for these attacks to contact their command and control servers. If you notice a problem, you want to disconnect from the networks immediately. This way, you can limit the damage, you can limit the cross-infection between all of your systems. And finally, you want to get insurance as a fail-safe. If this were to some way turn into a Linux to Windows, let's say ransomware, cross-infection, or scanning rootkit that scans, looks for Windows systems, it looks for vulnerabilities in the Windows systems, try to tunnel through, and then use ransomware on those Windows systems, and you ultimately decide to pay, regardless of whether or not there's a law in the United States that's passed so that you're not allowed to pay, it's against the law, or let's say you pay and then you get the decryption key and it still takes you 6 months to decrypt all of your network. The insurance can at least cover part of that. So with that, there we have it. This is the Facefish, new Facefish rootkit attack. I hope you enjoyed the video. If you did, don't forget to give a thumbs up. Don't forget to subscribe. I'm going to be putting out more and more videos as soon as I can, put them into a package that is understandable for most people. Hope you enjoyed the video, and I hope you continue to join me on this journey. Thanks, and see you on the next episode. Take care.